Hello and welcome to part 3 of the C# tutorial video series that we are recording to teach you the C# programming language. In the part 1 of the series, we basically did an introduction to the .NET framework and Visual Studio, where we discussed that the .NET framework, it actually helps you in coding and running your applications, and Visual Studio, it gives you a very good environment where you can write your code, compile your code, find out the errors, debug the logical errors, and do all those kind of things. In part 2 of this series, we basically understood the difference between C# and Visual C#, wherein we discussed that C# is basically a programming language using which you can write the logic for your software, and Visual C# is a complete technology that you can use to create the UI for your application, which will be a window based UI, a desktop based UI. Now in part 3 of this series, what we'll do is we'll understand the role of CLR in C# programming, right? So we discussed earlier in part 1 that CLR helps you in running your software written in C# and any other programming language supported by .NET, but today we'll majorly focus on how CLR plays a role. All the video tutorials for this series and for all other series we'll be recording are brought to you by my company, which is Mindful Software Solutions Private Limited, which is an ISO certified company. You can join us on our Facebook page, which is facebook.com/mindfulsoft, for getting in touch with us and finding all the latest things that we do. You can also visit our website specially made for educational purpose, which is ouronlinetutor.com, for all the videos, code samples, and text articles. So here you can get all these things in a very systematic, organized manner, so that you can search and read and watch whatever you want. The presenter for this video is myself, and my name is Ravinder. Alright, now to understand the role of CLR in .NET, what we have to understand first is that when we write programs using any programming language, where do we start from and where do we end, right? Now it's a very simple thing to understand. Like whenever you start writing a program, you write the source code using some programming language, which can be C, C++, or .NET. In .NET is C# or VB.NET or Java or PHP, any programming language, and all these programming languages are English like, so they are very easily understandable to humans. So they are almost, the syntax is all in English, right? And the final step is the final stage is, the first stage is you write the source code in using a programming language. The final stage is that you get the machine code, which is the final executable code that your CPU can understand, right? And how do we reach from a source code to the machine code? That is something which is done by a compiler, right? So this is the starting point and this is the ending point. Now to understand the role of CLR in .NET, we need to understand how C++, how C++ programming languages are converted into machine code, and how C# and VB.NET programming languages are converted into machine code, right? So it's basically a one-step process to convert C++ source code into the final machine code. So the compiler, the C or C++ compiler, would take your source code, convert it into the machine code. Now if you want to target a computer with 32-bit CPU and a Windows operating system, you need a different compiler to convert the C or C++ code into the machine language understandable by that platform, Windows on a 32-bit CPU. If you want to target, if you want to run your code written in C and C++ on a Linux machine, you need a different compiler to compile it for a Linux machine, right? So for all different environments, you have different compilers which will convert your source code into the final machine code, right? So if you want to target a Windows based environment, you have a separate compiler. If you want to target a Linux based environment, you have a different compiler, right? So it's a one-step process to convert the source code into the machine code. Now in case of C# and VB.NET and all other programming languages supported by .NET, it's not a single step process, it's a two-step process. In the first step, the compiler comes into picture, and the compiler will convert your source code into something called MSIL, which is the Microsoft Intermediate Language. So your source code is not directly converted to machine code. Your source code in the first step by the compiler is converted into the intermediate language. In the second step, the CLR comes into picture. Now the CLR will take your intermediate language in step 2 and convert it into the final machine code, right? So from your angle, from the user's angle, the user has no concern with what the CLR does. The user only has concern with what the compiler does. So from the user's perspective, if you look at the user perspective over here, so the user will think, oh, you know, if I have to run on a Windows platform, I need to use the TC compiler or the BC compiler, you know, or some other compiler which is supported by Windows operating system. Or if I have to, you know, run it on a Linux machine, I'll have to use a GCC compiler, right? So the user has a headache of, you know, selecting a proper compiler, following the syntax of a few things which are very specific to that compiler, right? But in case of, you know, using .NET technologies, the user is free of all these burdens. The user has to just write the source code in C#, compile it, and generate the intermediate language. All the other burden is taken by the CLR. Right. Now let's understand this in more details. Alright, now to understand this in more details, you know, let's just draw a conceptual model of a computer system. So at the very bottom of any computer system is the hardware. On top of the hardware is the operating system. On top of the hardware is the operating system. And let's first talk about programming languages like C and C++. So programming languages like C and C++ they are compiled into the machine code, which is specifically targeted for a given operating system and given hardware. So the compiler, in just step 1, in just a single step, will convert your source code into the machine code, which is then executed by a given operating system and given hardware. So if you are targeting Windows operating system, you need a separate compiler. If you're targeting a Linux operating system, you need a separate compiler. So you'll have to recompile your code every time you change the environment. This is from the perspective of the C and C++ languages. Now for programming languages like C# and VB.NET, this is not what the case is. For programming languages like C# and VB.NET, let me just draw a line over here. Now for programming languages like C# and VB.NET, they actually do not have any understanding of the underlying system. All they know is that there is something called a CLR. There's something called a CLR with which they will interact. So whenever you compile the C# source code in step 1, whenever you compile the C# source code using a compiler, a C# compiler, it gives you a Microsoft Intermediate Language. So it converts it into the intermediate language. Now this is where the CLR comes into picture. Now the CLR will convert the MSIL into the machine code, which will target a specific operating system and a specific hardware, right? So you know, if you are on a Windows operating system on a 32-bit machine, the CLR will be different. If you are on a Linux operating system on a 32-bit machine, the CLR will be different. If you are on a mobile platform, the CLR will be different. If you are on some other smart device, the CLR will be different, right? So it's basically a two-step process, and all these programming languages which, you know, .NET supports, they are actually called managed technologies or managed programming languages, because, you know, the target machine code that will be generated is actually all the responsibility of the CLR. So the user as a programmer has no responsibility to choose different compilers if they want to target different operating systems or different hardwares. Alright, let's, you know, sum it up, and let's again draw some clean diagram so that you understand the concept properly. So what is the .NET compilation model and the role of a CLR? In case you are using programming languages like C and C++, you compile them to get the final machine code, and it's the user's responsibility to select from different compilers according to different environments, right? So you have to compile separately for a Windows platform, you have to compile separately for a Linux platform, and you have to compile separately for some other platform. In case of C# and VB.NET, the process is simple. In step 1, the compiler will convert your source code into MSIL, which is the Microsoft Intermediate Language, and in step 2, the CLR will convert it into the machine code, which will then run on the target machine. So the user has no burden of selecting different compilers. The user only works with the one compiler, compiles it one time and converts it into the intermediate language, and then the CLR automatically, whichever CLR you are working with. So there's a different CLR for Windows operating system. Microsoft can give you a different CLR for a Linux operating system. Microsoft can give you a different CLR for an Apple operating system, right? They can give you a different CLR for a mobile phone. They can give you a different CLR for a smart device. So the CLR will decide according to which platform it is written, how to convert the intermediate language into the machine code. So that is the responsibility of a CLR. So as we said in the first tutorial also, that the CLR is responsible for helping you during the execution of your program. So now the user is free of mind, and the user will compile the code once and can run his code on different platforms. So this is one job that is done by a CLR. There is another very important job that is done by a CLR, and we need to understand that also. Suppose you are a C# programmer and your friend is a VB.NET programmer. So you have a habit of writing, you are very good with writing programs using C# programming language, and your friend is very good with writing programs with the VB.NET programming language. So when you write your code and you compile your code using a C# compiler, it converts it into the Microsoft Intermediate Language. When your friend will compile his code using a .NET compiler, it will convert his code into Microsoft Intermediate Language. And from this point, the CLR takes the charge, and the CLR has no idea that this intermediate language was generated from C# or was it generated from VB.NET. So for the CLR, intermediate language is just intermediate language, right? So if I ask you a question, what is the difference between C# and VB.NET? The answer would be nothing, because the only difference is their syntax. So C# has a C-like syntax, VB.NET has a VB-like syntax. So once they are compiled, they are converted into the same intermediate language, and the CLR cannot even tell which programming language was used to generate the intermediate language. So that is, these are two very strong things that you get from a CLR. Number one, you can write your code once and you can target it for different machines. Number two, you can write a project in different programming languages, and it can be then compiled into an intermediate language, and the same CLR can easily run it on different platforms, right? So if you have a team of people knowing different programming languages, you can make them both sit together and write the code, because their code will be converted into the intermediate language, and from there the CLR will take the charge. Now I hope you understand from whatever we discussed very briefly, I would say, about the CLR, the role of CLR in targeting your source code for different platforms, and helping people with different programming skills, C# and VB.NET, to work together, because the code will be converted in step 1 into the MSIL, and from there the CLR will take on the charge and will convert it into the machine code to target different platforms. So we'll just end this tutorial over here, and I'll see you in the next tutorial where we'll hopefully start talking more about C# programming language, and soon we'll start writing code and understanding the syntax of the C# programming language. Thanks for watching, and I'll see you in the next tutorial.